Before you know it, I just saw looks of horrors on fellow people standing by, and we just started running.
Destruction up and down the Oregon coast as high surf advisory continues for tonight. It is 11 o'clock. Good evening, everyone. I'm Jeff Gianola.
And I'm Jennifer Hoff. Tonight we're learning the Coast Guard calling off the search for a man who was swept to sea by those huge waves in Depot Bay.
Scientists are raising serious alarms as extreme conditions strike the Oregon coast without warning. Huge, unpredictable waves are slamming into coastal towns, overpowering defenses and catching forecasts off guard. Experts are speaking out with urgency and growing concern. What is happening along the Oregon shoreline right now goes far beyond what anyone expected. In the dark hours before dawn, with no clear warning or obvious buildup, the Pacific Ocean unleashed a violent assault. Massive waves surged with unusual power and erratic behavior, leaving emergency officials and scientists deeply worried. The events of this morning shattered every prediction, leaving coastal communities exposed and protective systems struggling after the first impact. Overnight, what should have been a routine winter weather watch turned into something raw and frightening. Reports flooded in of extraordinary wave heights reaching nearly 90 feet, swallowing entire beaches and slamming seawalls with shocking force. County emergency centers were quickly overwhelmed. Normal monitoring systems began to fall apart as alerts based on real-time sensor data could not keep up. Residents were jolted awake by vibrations moving through their homes and the unmistakable crash of water pounding the shore in total darkness. What troubles officials most is not just how large the waves were, but how unpredictable they became. These waves, generated by powerful storms far out at sea, struck the coast with almost no warning at all. Coastal roads vanished under raging tides. Rocky headlands were battered non-stop, and the line between land and ocean shifted almost instantly. By dawn, first responders described the scene as a coastal reset, as nature overturned long-held assumptions at a brutal pace. Even experienced meteorologists and ocean scientists, who have spent decades studying Pacific storms, admitted they had never seen such a powerful mix of ocean energy, ground movement, and strange atmospheric conditions. Fear spread along the coastline. Locals who know the usual warning signs sensed immediately that this event was different. This was not a normal storm. It felt like the start of a new era of risk and destruction. But the danger does not stop at what can be seen. What is unfolding along Oregon's coast is only the surface layer of a deeper threat. As waves crashed ashore, scientists detected unusual activity on the ocean floor. Tremors strong enough to shake cabinets and set wind chimes ringing hinted at powerful forces moving below. Emergency officials warned that what began as an attack of water could now be shifting the very ground beneath the coast, threatening everything built on top of it. Each new surge blurred the line between a natural disaster and a geological event. Questions quickly followed. How did this happen? Why did the ocean suddenly act with such force, defying all projections? What combination of forces pushed this event into unknown territory? Scientists say a rare and dangerous combination is responsible. Extremely intense Pacific storms, unusual seismic disturbances offshore, and an unstable atmosphere all came together, placing Oregon at the center of major coastal upheaval. As daylight revealed the damage, one question grew louder than the roar of the surf. If danger can arrive this suddenly and this powerfully, what other threats may still be hiding beneath the waves? Just hours before disaster struck, the Oregon coast was calm under heavy clouds. Fishermen prepared for the next winter storm, and locals, hardened by years of rough seasons, trusted their seawalls and familiar cliffs. Conversations in harbor cafes focused on fishing and talk of monster waves, which until now felt more like rumor than reality. That sense of normal life was shattered by what was forming offshore. As night fell, scientists at the Pacific Northwest Seismic Research Center noticed troubling signals. Sensors miles out at sea sent back erratic readings. Seismic tremors appeared beneath the growing hum of an intensifying Pacific storm. The data didn't match known patterns. Wind-driven wave energy overlapped with vibrations more typical of undersea earthquakes. Concern grew rapidly among researchers. Dr. Marcus Holloway's team flagged the readings as an unprecedented convergence, a warning to anyone familiar with the coast's violent history. A disturbing question hung in the air. Could a strengthening storm and sudden tectonic activity combine to supercharge waves beyond normal limits? Data suggested that was exactly what was happening. Onshore, officials issued watch advisories but hesitated to order evacuations. The horizon looked deceptively calm, yet numbers from offshore buoys raised serious alarms. No historical record or storm database could explain the collision of atmospheric and seismic forces developing offshore. As midnight approached, animal behavior changed. Dogs barked toward the ocean. Seabirds moved inland. Locals sensitive to nature felt growing unease, a low vibration underfoot, and an unnatural tension in the air. Most people would not understand what these signs meant until it was nearly too late. Official records state the disaster struck before dawn. In reality, it began hours earlier as unseen surges moved quietly under cover of darkness. At exactly 4:17 a.m., a single wave close to 90 feet high was recorded approaching near Newport. A towering wall of water, lit only by moonlight, advanced with terrifying speed. Within moments, the ocean pushed hundreds of yards inland, erasing dunes, flooding roads, and ripping apart parking areas. Even veteran observers were stunned. Witnesses described the impact as explosive. Houses shook, windows shattered, and seawalls cracked. In Yachits, long stretches of shoreline disappeared beneath the water. Vehicles flipped, cabins were dragged off foundations, and debris filled the surf. On headlands, the force of the waves seemed to shake the ground itself. Emergency calls overwhelmed dispatchers almost immediately. "The waves keep coming," one caller from Florence said. "The roads are gone. It's like the ocean is wiping the land away." In Depoe Bay, the boardwalk was torn apart. Responders trapped between rising water and collapsing ground rushed to locate missing residents as wave after wave struck. What unsettled officials most was the silence before the disaster. There were no clear warnings. The ocean usually signals danger with falling pressure, roaring winds, and obvious buildup. This time, those signals were missing. No rising winds, no violent gusts, no clear evacuation cues. The strike came suddenly and far outside expected limits. By dawn, the scale was undeniable. This was not just another winter storm. It was a catastrophic convergence. Rare storm energy amplified by offshore seismic unrest. From Brookings to Astoria, Oregon's coastline became ground zero for an event Dr. Marcus Holloway said should not have been possible, yet now redefined what is considered realistic. As helicopters surveyed destroyed highways and flooded neighborhoods, one question echoed again and again. How could the ocean turn so violent? Driven by forces beyond wind and water alone. Researchers pieced together a troubling picture. This was not just about tides or storms, but a rare interaction between atmosphere and tectonics felt in every silent home after the first wave. Two main forces drove the event: an explosive winter storm in the Pacific and renewed seismic activity on the ocean floor. Days earlier, sensors detected growing vibrations under the sea, a warning sign of instability along regional fault lines. Tremors strong enough to rattle windows were felt up and down the coast. At the Cascadia Oceanic Institute, Dr. Abigail Renard's team worked urgently to connect the data. "We've seen big waves and tremors before," she said, "but never together and never this strong." Her team traced the cause to a sudden drop in atmospheric pressure timed perfectly with seismic movement, triggering what scientists call a compound surge, a process that multiplies wave height, speed, and force beyond standard models. The result was devastating. Long-traveling swells grew larger as they crossed the Pacific, then intensified again when they encountered seismic disturbances near Oregon's undersea faults. Every planned barrier and warning system was overwhelmed. Offshore buoys tried to send alerts, but the window between detection and disaster had shrunk to minutes. "Normally, we see danger building," Dr. Renard explained. "This time, The event outran our fastest warnings. For coastal Oregon, the disaster tested not just infrastructure and budgets, but long-held scientific assumptions about regional risk. While technically possible, experts agreed the event was so rare it nearly defied probability. With tremors still faintly registering offshore, fears remained that worse could follow. Damage spread far beyond flooded neighborhoods and broken seawalls. With every tide, the land itself weakened. In Gearhart, dunes collapsed into jagged lagoons. In Tillamook, sections of the coastal highway fell into churning water. Emergency crews struggled to keep up as villages were cut off and lifeboats rescued families from second floors. Streets became unrecognizable. Beneath the surface, an even quieter threat emerged. Geologists detected slow but steady ground movement along battered bluffs. "We're not just fighting water," said Dr. Victor Jang. "The land itself is moving." Erosion sped up after the seismic activity, creating long-term dangers that may last months or years. As power stations flooded and communication towers failed, officials began calling the event a compound hazard disaster. Water, earth, and weather combined in ways that traditional emergency plans could not handle. Evacuations pushed farther inland than ever expected. As night returned, anxiety deepened. If the Pacific could create this convergence once, what might the future bring? Are isolated disasters being replaced by events that interact and multiply? By midday, normal life along the coast had vanished. Areas long labeled low risk flooded for the first time. Roads rebuilt after past storms failed in minutes. Schools became shelters. Communities were cut off. "This storm changed everything," Dr. Renard said. "Our systems are built for single threats, not multiple ones happening together." Insurance plans, zoning laws, and evacuation strategies suddenly looked outdated. As the ocean continued reshaping the coastline, one reality became clear. This was not a single event. Each tide deepened the damage. Rivers reversed direction. Inland valleys flooded from below. Hillsides cracked and slid. Satellite images showed washed-out highways, reshaped estuaries, and drowned forests. In the quiet after the assault, the psychological impact settled in. The Oregon coast, once trusted for its strength and permanence, now faces a future of uncertainty. Scientists, officials, and residents ask the same question. How do you defend a coastline when risk no longer follows old patterns? Standing among the wreckage, Dr. Holloway summed it up simply: "We are in a new era. Every protective measure has been pushed beyond past limits." Yet, amid the destruction, resilience appeared. Neighbors helped neighbors. Volunteers worked nonstop. Communities adapted. Scientists say Oregon's coast is now a warning, a lesson in what happens when rare disasters overlap and margins disappear. The ocean must be understood not just as scenery or threat, but as a powerful, changing force. As families regroup and eyes stay fixed on the Pacific, one truth remains: the coast will not return to what it was. But with awareness, preparation, and learning, survival, and even resilience is still possible. Stay alert. Stay informed. Your preparedness matters.